So tonight I want to talk about becoming a well-balanced programmer. And since somebody asked me this on Twitter, I want to be clear right off the beginning that I'm not going to be talking about work-life balance, not that kind of balance. I have a couple of other kinds of balance in mind, one of them that has to do with the balance of knowing many things. It's not enough just to know how to write code. It's not even enough to know how to write code well, but I also want to talk about other ways of being balanced, such as the illusion of control. So I prefer to use the word balance instead. With any luck, feeling a little bit better balanced than I feel right now on stage. And so, no, this isn't going to be 40 minutes of talk about work-life balance, so if the one of you who asked me about that on Twitter is in the audience, it's okay, you can pay attention. When I decided to become a professional programmer, I certainly felt out of balance, out of control. One of the first and most significant things that I came up against was the problem of bugs, or as I prefer to call them, mistakes, because that's usually what they are. And I was drowning in mistakes. I was that kind of programmer who spent every day thinking that I had achieved something and then realizing that every time I fixed a problem, I created two more. And if you do that long enough, everything falls apart. And that's exactly what happened to me in my very first project. And so that was just one of the many reasons, one of the many ways that I felt out of balance. Somehow, I managed to do enough good work that my employer made the dubious decision to make me a technical lead in my team. I'm not sure that was a good idea. And I noticed that I was out of balance in that I tried to do too many things. And it was evidenced by the literal queue of people lining up outside my cubicle, waiting to ask me questions. I had turned myself into an individual knowledge bottleneck. And the result of that was that at some point the project couldn't move forward without me. And that's a terrible place to be. You shouldn't depend on one individual person for the success of your project, and you certainly shouldn't depend on the 24-year-old me. That's risky and invites failure. And in spite of this long queue of people waiting to ask me questions, in spite of this feeling of being an individual bottleneck and therefore kind of feeling important, that led a little bit to that. That's that notion of Parkinson's law, right? That work increases in perceived importance until suddenly it takes up all the time available. And yet, what I was doing really didn't seem to matter. One of the books that you'll hear people quote quite frequently is Daniel Pink's Drive, which I'm told is a very fine book, but I much prefer Patrick Lencioni's The 3 Signs of a Miserable Job. And two of the 3 signs of a miserable job are two things that I experienced in my time in my early career. I felt immeasurable, which meant that I really didn't have a way of judging whether I was doing good work. I mean, I was doing work. I seemed to be doing a lot of it. People seemed to be asking me questions, but I didn't really have any way of measuring the results that I was creating. And so I felt entirely like I had no idea whether I was doing well or not. I could get mixed signals from everywhere around me. And at the same time, I felt incredibly irrelevant. It seemed like the work that I did just didn't matter to anyone. I remember counting one day how many people there were between me and a paying customer. And there were 17. 17 people between me and a paying customer. In fact, I remember when I think I told this story yesterday, or 2 days ago. For those of you who have heard this before, you can take a 45-second nap. I remember distinctly this situation where I had just discovered extreme programming. What a wonderful thing. It was the year 2000, the idea was still quite fresh, it was just becoming popular, the early adopters were really getting on board. And I was running up and down the halls at IBM screaming, "We have to do this, we have to do this, this is the only way to run software projects, why aren't we doing this now?" And one of my colleagues, 20 years older than I, which means that he was as old then as I am now, asked me if I'd ever read an IBM annual report. And of course, I told him no. I mean, I understood financial statements a little bit. I had basic financial literacy, but I'd never bothered to read an IBM annual report. And so he had me read a profit and loss statement that showed that the 2,000 people in the building I worked in accounted for less than 1% of IBM Canada's revenue, which, as you can imagine, is a fairly small fraction of IBM's global revenue. And so he looked at me and he asked, "Now do you understand why nobody gives a shit about this test-driven development you keep yelling about?" And so I felt, I had signs that I was doing good work, and yet ultimately I felt like I couldn't really measure what I was doing. I had no objective way of seeing value in the work that I was doing, and it didn't seem to matter anyway, because by the time I got something done, I had no way of knowing whether a customer was even using it. In fact, I think in my 4 years at IBM, I spent 2 glorious days working with a real customer. And we did that much work in 2 days, and it made them happy. And I needed to leave IBM in order to be able to duplicate that experience as a freelancer. At the same time, I was arguing a lot. I was young, arrogant, abrasive. You couldn't imagine it now, but that's the way I was back then. Okay, I know it's getting towards the end of the day, but that was a laugh line, so we'll try that again. I was young, arrogant, abrasive. You wouldn't imagine it now, but that's the way I was back then. Thanks, that's the exact amount of laughter for that joke. I argued with a lot of people, and I thought that I was doing the right thing because I was arguing from a place of genuine disagreement about things that mattered. The kinds of things that Patrick Lencioni in the 5 Dysfunctions of a Team would call ideological conflict, the kind of conflict that you want to have. Unfortunately, many of those arguments turned into fights, or, as I'm told, clarifications of relationships. Okay, I think apparently I got that right. And part of the reason for those arguments, part of the reason that those turned into fights was that ultimately, in spite of my arrogance and in spite of my abrasiveness, I felt incredibly insecure about my own career. How could I not? I was buried inside this monolithic organization. I had no idea whether anybody cared whether I came into work or didn't. Nobody seemed to use the results of my work. Therefore, I couldn't tell whether I was doing a good job or not. Everything was entirely out of balance. Senior people tried very hard to advise me, but I just wasn't ready for the kinds of things that they were trying to tell me. And even after I left IBM, I can remember one horrible experience where I was with a client and I had a little bit of free time and needed to take an emergency conference call from another client. And my business partner at the time and I were on this call, and it was some difficulty about some contractors that we had placed with them. They weren't doing the work that they expected to be doing. They thought they were going in there as coaches, and instead they were being asked to be warm bodies, to be just a programmer. And this was creating a lot of tension, a lot of conflict, and I thought, well, maybe I can help. And I got on this call, and I'd never had this experience before or since. I asked what I thought was a fairly innocent question in a fairly calm tone of voice. Well, what do you know about pair programming? And I got a 13-minute long lecture answer. Wasn't so much, it was partially lecture, partially complaint. I don't even really remember much about it except that it went on for a really long time. And I thought, well, let me try this again. I'll ask another calm, simple question. And I asked a calm, simple, straightforward question. And this time, the answer was 18 minutes. Clearly, this person was upset with how this interaction was going, and I couldn't understand it at all. It was like being in a nightmare that I couldn't wake up from. And when I got off the call, my business partner at the time tried to advise me, tried to tell me, you need to... I was asking, what the hell happened? All I did was ask 2 questions, and I got 30 minutes of being yelled at by somebody who doesn't even know me. Why the hell did this happen? He said, well, because you sounded passive-aggressive. I couldn't understand it. I felt the pain, and I couldn't understand where the pain was coming. I couldn't understand why this was happening to me. And he tried to give me some advice. He said, you've got to think of them like fuzzy kittens. You've got to cradle them in your hands and speak softly to them. And then maybe they'll listen to you. But you can't just go in there, somebody you've never met, and ask these direct questions. They feel threatened. They'll jump away. Okay, so I had this pain. I had somebody trying to give me a trick, but I couldn't understand why I should have to do that. Surely we're all professionals. There's that word. Surely we're all professionals. Shouldn't this have worked? Unfortunately, the principles, the ideas that helped me put the pain and the trick together just weren't there yet. And so I wasn't ready to take this advice. I needed the pain, the principle, and the trick to come together at the same time before I could really make this advice work. And so what I'd like to do today is to share some principles and some tricks with you that I use to become better balanced, hoping that some of your pain mirrors some of my pain. I'd rather not create the pain for you. I think that would be sadistic, I think by definition. What I'm hoping is that we have shared some of the same pain, that my personal experience and the experiences of the hundreds of programmers that I've worked with over the last 15 years will match well enough that as I try to give you these principles and these tricks, maybe then they will arrive, some of them, at least one of them will arrive for you at the right time. And so the first pain that I like to start with was the pain of significant work falling through the cracks. This happens to me a lot. Where I'm sure you've seen, another one of those 4-quadrant models that are so popular among consultants, that on one axis you have important and on the other axis you have urgent. I don't like to get into arguments about what important means, so I tend to use the word significant. And so you have some work that is significant and urgent, and obviously you do that right away. You have some work that is not significant and not urgent, and you never do it or give it to somebody else to do. You have work that's urgent but not significant, which you do only if it's a condition of your employment. If it's the thing that stands between you and collecting money, then you do it, otherwise you throw it away. And then there's the tricky quadrant, the significant but not yet urgent stuff. And I say not yet urgent because if it's significant, and you wait long enough, it'll become urgent, especially if you let it slip through the cracks. And then somebody screams at you wondering why you haven't done this thing, and suddenly it becomes urgent. And this was happening to me over and over and over again. In spite of my best efforts, things just kept slipping through the cracks. I kept forgetting things. Deadlines snuck up on me. Commitments that I made came back 3 months later, and people were wondering why I hadn't done anything yet. And so I had to learn something in order to help with that. Now, when I was younger, I thought I could just keep all this stuff in my head. In fact, I think it's particularly a disease of especially young, especially male, especially programmers. That we think we can carry all this stuff in our heads and that we wear it as a badge of pride. I certainly did. I'm not saying any of you would, but I'm guessing from a little bit of that laughter that maybe you know somebody who behaves like this and maybe that someone is you. And so I had to learn something that would help me deal with this, and that was when I learned getting things done. And I know the irony of encouraging people to read a book when they already don't have time, which is why I've written a 4-page guide on how to get started with getting things done, and can even boil it down to getting started with the 2-minute rule. I can teach you the 2-minute rule now. If somebody asks you to do something and you think you can do it in 2 minutes, then do it. And if not, then you have to plan it for later. Now, what's really important here is that 2 minutes goes by fast. I probably think I've been up here for 3 or 4 minutes, and yet it has been more than that. 2 minutes goes by quick. I highly recommend, now that we all have digital timers in our pockets, I recommend that the next time you think you can get something done in 2 minutes, that you start by setting a timer for 2 minutes, and when the timer yells, you stop. You do that 5 or 6 times and you'll start to get an appreciation for how quickly 2 minutes goes by. It's like that. And so if you can't get it done in 2 minutes, then you have to plan it. And if you don't know how to plan it, then you read the 4-page Getting Started with Getting Things Done guide, and when you've gone through that, then you probably have time to read the book. But I don't want to make this a symposium on getting things done. It's just that this was one of the tools that I needed at the time that really helped me get these things under control. The image that I like to use is, imagine building a system that you trust so well that it behaves like a black box sitting on your desk. And the black box has a red button. And when you finish a task, after you have celebrated and had coffee or tea or wine or beer or whatever you drink at work, then you go over to the box and you hit the red button and a ticket pops up saying, do this next. And in getting things done, the first thing that really attracted me to it was the idea of this black box that I could just put information into this system, and then later when it came time to do things, I could just hit the button, read the ticket, and feel very confident that what I was doing was urgent and probably significant. And that feeling, that really attracted me in the beginning. That part of getting things done is the thing that really made it click for me at the time. There's more, and we'll come back to that a little bit later. But getting things done gave me a clear model for removing stress from doing significant work. Because what it allowed me to do was to not worry about the stuff that would never become urgent. But instead, there are little tricks in there that you can use to stop that significant work from becoming urgent without you noticing. One of them is called a tickler. The idea that there's this little alarm that goes off that says, hey, it's time for you to start thinking about this. Here's a project that's going to take about 3 months to do. You probably want to do it sometime in the next year and a half. So if you haven't already started it by then, in 14 months, I'm going to ping you and say, hey, it's getting close. Now's a good time to start thinking about this. I've showed a couple people here a service called followupthen.com. And so if you want to get periodic reminders or reminders based on time, then you can just take your phone out right now and send an email to 1min, 1 minute, at followupthen.com, and you'll get that email back in 1 minute. Which means that you can do this for things like, as soon as somebody invites you to come to a conference, and you know that conference is in this part of Paris, you can book a hotel right now because usually you can cancel free, right up until the day. And so then all you need is a reminder about 2 weeks before the date that you're due to check into the hotel that says, hey, if you don't need this reservation anymore, cancel it so that somebody else can book that room. And between now and then, you can put that completely out of your mind. It allows you to put all those things that you would ordinarily worry about, the stuff that you were carrying in your head, gone. What a gift. This was the thing that really attracted me to this at the beginning. And so, as I say, getting things done gave me a clear model for removing stress from doing significant work. So here I was at IBM. I was drowning in my own mistakes. And I came across this strange little book called Extreme Programming Installed. In fact, I didn't even come across the original book. I came across a preprint of the book, and I like to make sure that I tell Ron Jeffries every time I see him that I still have never paid for this book. And this was the book that told you how to do extreme programming. And from that, I learned this thing called test-first programming. And I played around with it a little bit, and the idea was that I could actually find my mistakes before I made them, or the moment I made them. It's like having a red flashing light on my computer that said, hey, idiot, you made a mistake in the last 15 seconds. Hit undo and try again. And I ended up in a situation where I had written code for 3 months, and I was creating problems more quickly than I could fix them. And I was in one of those Friday status meetings that IBM was famous for. My manager asked me that question, how's it going? And I couldn't just say 80% done this time, which is the normal answer. I had to say, you know what? I'm not going to finish. It's not going to happen. Sorry. Every time I plug a leak, 3 more spring up. I have no idea where they're coming from. What do I do? Well, the good news is I discovered this thing called test-first programming. The basic idea is that I'll write tests as I go, and at least when I try to build the next part of the system, I know I'm building it on top of a foundation that works. It might not be pretty, it might not be great, but at least it works. For some value of works. I said, now the bad news is I don't think I can finish this on time if I continue the way I'm going. The good news is I think there's enough time for me to write it again. We've got 3 weeks until code freeze. Let me go home and let me work on it. And I think I can build it again. And if I walk in here in 3 weeks and I haven't built it again, you can fire me. Ah, the arrogance of youth. So the short version of the story is that I managed to get it done in 9 14-hour days. You know, wake up every morning, inject coffee, fire up the laptop, which of course was slow because it was probably a Pentium 200 at the time, and crank out code. And at least writing the test first, I had this wonderful, steady feeling of progress. And there were times where I would, in exhaustion, run the tests, and of course they would take 12 minutes to run because I didn't know what I was doing, and I would run the tests, set an alarm, and take a nap. And then the alarm would go off, boop, I would wake up, I would look at the test result and go, oh shit, make a change, set the timer, run the tests, and I would do that. I was literally making 4 changes per hour for the last half of this work. And I still managed to do in 9 14-hour days what I couldn't get done in 3 months prior. Now, some of that is second system effect. But some of that had to do with the idea that I had this, even in this feeling of exhaustion, I still had confidence that I was building on a solid foundation. And this worked very well for me. I kept my job. But then suddenly I started to have a different problem. The problem had to do more with designing myself into a corner. I know you wouldn't make this kind of mistake, but sometimes, even when we think we know exactly what it is we're trying to build and we draw this beautiful diagram that shows how everything fits together, and even if we use test-first programming to type everything into the computer correctly, somehow when we try to put things together, they just don't quite connect. Right? In the best case scenario, this module does too much, that module does too much, and they overlap. Well, that's good because you delete some behavior from one of them and everything's cool. In the worst case, I didn't do quite enough on this side, I didn't do quite enough on that side, and something fell through the cracks in the middle. Great, now I thought I was done, and evidently not, because when I put things together, they don't even reach, forget about fitting. I started to notice that design was the problem. Design had become my biggest problem. And that's when I discovered that this idea of test-driven development, the idea of using the refactoring step of test-driven development to do most of the design work. See, when I first read about test-first programming, they talked about refactoring all the time, and I kind of understood a little bit about what they meant, this idea that you could change the structure of the system without changing the behavior sounded kind of interesting. It sounded curious. I wasn't really sure what value it had until I got past the point where bugs were my big problem and to the point where the design was my big problem. And then I started to see test-driven development as a way of helping me improve the design of systems, a way for me to generalize the system just enough in just the right direction at just the right moment. And it also took a lot of the strain out of working as a programmer because I didn't have to worry about what was coming next. All I had to do was solve enough of the problem for right now, confident that when I needed to change it, when I needed to generalize it, I could do it just enough in just the right direction at just the right time. Later on, I even realized that I could use test-driven development not just for designing my own systems, but for really understanding what it means to design software systems. It became the centerpiece of how I teach programming to other programmers. It became a way to learn deeply the principles of good modular design in a way similar to the way that we learn languages, by example. The one great thing about doing any kind of evolutionary design is that you see a whole bunch of examples of code and slightly better code, code and slightly better code, code and slightly worse code, code and slightly worse code. And so you build up this catalog in your mind of how these principles work. So that if, like me, you tried to read books like Object-Oriented Analysis and Object-Oriented Design with all their wonderful code samples in Smalltalk and Eiffel, what the hell is this? I might as well have just smacked myself in the head with the book because it had pretty much the same effect. But when I got to see it for myself, by example, step by step, it allowed me to learn just what I needed to learn to make the design a little bit better as I went along. The pain, the principle, and the trick all came together at the same time. And so it was easier for me to learn. And gradually I began to understand what all this object-oriented nonsense was all about. And I've even noticed that as someone who practices test-driven development in largely object-oriented languages, that taking the principles even farther led me in the direction of writing my object-oriented code in a very functional style. Not an extremely functional style, but a somewhat functional style, with heavy emphasis on immutability. This became convenient for testing. What I learned is that test-driven development had helped me even move in the direction of understanding modularity as a general concept and not just about how to do good OO, especially now since good OO is going out of style. Well, that's okay because structural's coming back, right? So we're in good shape there. It's good to know that all three of them are exactly the same. So I use test-first programming. You'll see articles out there on the web about TDDs about design, not about testing, stupid. Well, congratulations that you learned something. I don't know that that means that everybody who hasn't learned that yet is stupid. I think it just means that they're a little bit farther behind in the journey than you are. And so these are sort of the 3 stages of learning test-driven development. I would say there are 3 stages, not the 3 stages. When mistakes are your biggest problem, then you focus on test-first programming in order to get the behavior of the system under control. And then when that stops being your biggest problem, that's replaced by your second biggest problem, which is probably designing yourself into a corner. And with test-driven development, you can design yourself out of the corner just as easily as you designed yourself into it. And gradually, you might even learn how to use test-driven development as a mechanism for deeply understanding the principles of software design, the good modular design principles, the solid principles, coupling and cohesion, all the stuff that we've been told are good ideas. That test-driven development doesn't just help me improve the design of this system, but helps me really deeply understand the forces and tricks and techniques that lead to better design. One other thing that I learned from practicing test-driven development was the value of stopping. One of the things that I like to say is that writing the test first cures one of the most prevalent problems among programmers, and that is that they don't know when to stop. You just keep typing and keep typing and keep typing and keep typing, and you hope that you have typed enough. I mean, again, not that you would do any of that, but some of your coworkers are probably creating that problem now. You would never do that to them. And one of the nice things about writing the test first is that when the test passes, you stop. I want to write more code. Can you think of any more failing tests? No. Well, then you don't get to write more code. Stop. Refactor. Take the code you've got and make it better. It's probably bad enough as it is. One of the wonderful things about practicing test-driven development is that it reminded me the value of not doing things. It's also one of the things that I remembered learning from extreme programming, right? Isn't that right in the Agile Manifesto, maximizing work not done? And in getting things done, one of the first things that you do after you apply the 2-minute rule is you then go through the list of Ds. And the first D in planning your work is delete. My favorite reaction to "could you do this please" is nope. And that should be your favorite reaction, your favorite reply to the question, "would you do this please?" Is it going to take more than 2 minutes? Yes. Will you do it? Nope. And if you can't do that, then try to get somebody else to do it, right? If you can't delete, then defer. Or sorry, delegate, and then if you can't delegate, defer. Can I do it later? Sure. Okay, it goes in my list. I don't have to worry about it now. At some point later, I'll hit the red button on the box. The ticket will come up. Ah, time for me to do your thing. Lucky you. Between test-driven development, getting things done in XP, it really crystallized for me the idea of not doing things. We have the idea of you aren't going to need it. I would even add to that maybe my favorite, which is you aren't going to do it. When Mary Poppendix suggests that you take your backlog and take the bottom 80% of it and just set it on fire, I find that to be particularly good advice. Because if you have something that's been sitting on that backlog for more than a few weeks, and certainly more than a few months, then you aren't going to do it. That's liberating. It's great to decide that you're not going to do something, because then you don't have to do it anymore. This is one of the things that helped me become more balanced. Test-driven development gave me a clear model for removing stress from programming. It was even there where in fact, one of the first things that I remember reading in test-driven development, in Kent Beck's book, Test-Driven Development by Example, in the back he talks about the test list. Before you start programming, write down the tests that you think you need. You don't have to write down a perfect list, just write down the tests that you think you're going to need. That gives you kind of a checklist. It gives you a place to get started. And then as you're working, sometimes you'll add stuff to the list. And as you make tests pass, you cross them off the list. And as you notice a refactoring that you want to do, you add it to the list so that you can do that before you're done. And at some point, everything on the list has been crossed off and you're done. This is also taken directly from getting things done. The principle of getting stuff out of your head. The idea, this is, again, where I was ready for the next trick, the next principle. That getting things done wasn't just about creating this black box that you could trust to tell you what the next thing to do was. But the idea, the sheer power of getting stuff out of your head. Nothing is more powerful to a programmer than focus. And getting stuff out of my head gave me the opportunity to focus on the thing that I was working on right now. I don't have to do anything else. I don't have to worry about the next 4 steps. I don't have to worry about this meeting this afternoon because my phone is going to ring 5 minutes before I have to leave for that meeting. I don't have to worry about the stories that we're going to have to work on next week, next month, next year. I can focus on this one thing, give it all my attention, and do it extremely well, and avoid making mistakes that then create unplanned work later. Few things slow us down more than making mistakes. And so I offer you this. This is, I like to call it a proven path to effectiveness, because I like to choose these ridiculous names for marketing purposes. Don't take it too literally. It's there purely to be memorable. And you can see how you can combine getting things done and test-driven development to help you as a programmer get off that treadmill of overcommitting to things, getting things wrong, forgetting to do things, falling late, creating problems, shipping bugs, all the things that create stress in our work as programmers. This is one of those little mini feedback loop systems that allows you, it gives you a path to get out of that mess. Not the path, it's not the proven path to effectiveness. A proven path to effectiveness. Proven, of course, because all you need is an existence proof, and it worked on my machine, so there you go. This became a way for me to remove stress from my work. And what's amazing is that when you remove all this stress from your work, then the question, what's next, becomes interesting. You can actually feel free to start thinking about that. And what was next for me was trying to encourage other people to practice test-driven development. When I discovered this for myself, when I realized that this is what was happening to me, I immediately wanted to share this with everybody because it's so wonderful. I mean, the feeling is great. I would teach it to people. And so I thought I would teach test-driven development because the getting things done thing is really sort of I can't get anyone to pay me to teach them getting things done. They shouldn't. There's a book, they should go read the book. Done. That's really it. There's not that much to it. There's a book, you follow the instructions, you try it. There's really not that much to it. But test-driven development is a little bit more nuanced than that. And so I set about teaching the world to do test-driven development. And I started having difficulty getting other people to practice it for a variety of reasons. So I wrote a book, and I did training courses, and I moved those training courses online, and I started a blog dedicated to evolutionary design and test-driven development called The Code Whisperer. And I practiced and practiced and practiced at answering people's questions, because I figured, well, if I have the right answer, then that should be all they need. They can just go ahead and do this now. And strangely, it wasn't until I got all my big ideas out into the world, at least the ones that I had at the time, that I started doing this magical thing of listening to people. And as I listened to them more and I heard what they were having trouble with, that's when I really started to make connections with them. And all the tricks and the techniques that I was trying to push at them, I finally realized that I don't need to push anymore. I can be more balanced. I can instead engage people one-on-one and find out what is it that's really bothering them right now, and then feed them one or two little tricks or one or two little principles that can help them move forward. Because again, if the pain and the principle and the trick don't reach at the same time, then you won't necessarily move forward. You'll be out of balance. So it's really nice to know that Linda's advice helped me even before I understood that it was Linda's advice. That actually listening to people made a big difference. There's a clue there. Now let's talk a little bit about code. One of my big pains at the time was complicated tests that led to painful refactoring. This is a problem that a lot of programmers have. They experience at some point. And as a result, they start to conclude that this test-driven development thing isn't working. But I remembered that I had read this article about something called the dependency inversion principle. Bob Martin was raving about this crazy idea sometime in the mid-90s in some C++ journal about dependency inversion. I didn't really understand it at the time until I started to notice that the tests were too tightly coupled to my production code, and that was getting in the way of refactoring. I thought I was doing the right thing, and it wasn't working. And I started to ask why. And only at that point, when I had the pain and the trick, somebody reminded me of the principle. Hey, the dependency inversion principle is going to help you here. You've got too many details buried too far down deep in your code, and those details are what's getting in the way. Those details are preventing you from writing tests that clearly link the input to the expected output. Once you pull those details or push those up the call stack, then what's left behind is much more abstract, much more reusable, works in other contexts, doesn't depend on those details. It isn't so sensitive to those details, and it becomes much easier to test. And it wasn't until I had been beating my head against the wall for a couple of years that I was ready to hear this. And so one of the practices that came out of the dependency inversion principle was this idea of move details up the call stack. In my mind, the entry point is up here, and the belly of the system is down here, which I know is the exact opposite of how stack traces are usually displayed. Not my fault. It's just the way my brain is working. So pushing details up the call stack became this magic trick that essentially took all the unstable code and moved it up where there were fewer clients. Ooh, that sounds reasonable. If code is unstable, then isn't it a good idea to have fewer clients so that there's fewer clients to disrupt when things change? It seems to me that you want the unstable code to float up to the top, leaving the more stable code to settle to the bottom. Those become those abstract data types. Those become the things where you can take full advantage of things like the Liskov substitution principle. And so as I like to say, one of those things that crystallized for me this week, that the Liskov substitution principle plus the dependency inversion principle might be the single most important part of the solid principles. In fact, much more important than the single responsibility principle. Discuss on Twitter. Now I had better tests, but I had a lot of confusing indirection. And what I started to notice was that this indirection was making my code difficult to understand, even though it seemed to be, in principle at least, well designed. And that's when I realized that I was ready for the next idea, to focus on abstraction. So I'd like to take just a moment to talk about abstraction. I promise this will be quick. Programmers like to use the word abstraction a lot, but I'm not really convinced that they understand what it means. It's very complicated, so I'm going to try to summarize it. In fact, I'm going to summarize it in 2 words. You ready? Abstraction means hide details. That's it. That's it. That's all abstraction means, hide details. Figure out the things that you don't need to know and don't know them. Hey, wait a second. That sounds an awful lot like figure out the things you shouldn't do and don't do them. Aha, we're starting to see some commonality here. Don't force me to know things. That's all abstraction means. Think of a chair. We have lots of chairs here. There's lots of chairs out there. Why do we just call it chair? Why don't we call it mobile, 200 kilogram capacity, composite, metal and fabric seating device, which is what we would call it in C#. Why do we call it chair, or I guess in C# iChair? Because all we need to know as clients of the chair is that I can pick it up and put it where I want to, I can sit on it, and there's a very good chance I won't die. That's the interface of chair. And some chairs aren't even mobile. I just chose that as an easy example because you could actually pick up these chairs and move them. Who are the people who are interested in the details of 200 kilogram capacity, composite, metal and fabric, 4-legged, blah, blah, blah? Who really cares about the C# class name for chair? The people who build chairs. The people who are involved in the details of building chairs are the only ones who should care about the details of how to build a chair, and the rest of us should just use it through iChair. Move, sit, don't die. That's it. And this led me to really understand what modularity was all about. Abstraction. As I like to say, you can have modularity or details. Pick one. And if you're obsessed with details, you're not going to have modularity. When you become interested in modularity, you can't have details. That's the point. And abstraction is just hiding details. What is the least I could possibly know about you and still use you correctly? That is how I learned to think about design. And this led to a pattern that I'd like to share with you, which is not original, but I like to think is a little bit original in its presentation. The universe is divided into 3 categories of things. Inside this circle here is the happy zone. In the happy zone, it's always 26 degrees, there's a light breeze, everything runs in memory, there's just everything is deterministic, straightforward. You could do it on a Turing machine. In fact, you would do programming the way I want to do programming, which is on the Turing machine in my head. That way we could avoid the 2 things that ruin software, which are people and computers. And then outside, we have the horrible outside world. The horrible outside world is where the dragons are. That's all the stuff that's trying to kill you. Now, the bad news is the horrible outside world has all the stuff that's trying to kill you. The worst news is that it's where everything interesting lives. Everything that you need to actually make a system do something, beyond 1 + 1 = 2, is in the horrible outside world. Now, in between the happy zone and the horrible outside world is the DMZ. The job of the DMZ is to protect the happy zone from the horrible outside world. Right? You fish on your side, I'll fish on my side, nobody fishes in the middle. And so now we can start to talk about some rules for how we let things depend on each other. So for example, something inside the happy zone can depend on something else in the happy zone. Something in the DMZ can depend on something else in the DMZ. Something in the horrible outside world, really, I don't care. Not my problem. I don't make things that live in the horrible outside world. Something in the DMZ can depend on the happy zone. The happy zone includes things like value objects and interfaces, all the little things that we can run entirely in memory, the things that are very easy to test. And so we'll have some things in the DMZ that depend on things in the happy zone, and occasionally, if you're lucky, there will be something in the horrible outside world that will depend directly on stuff in the happy zone. So for example, back in the old days when I didn't know whether to use struts or Spring Web MVC, that's how old I am, I wanted to know what was test-driven development friendly, and I found out that there was one big difference between these two frameworks. In struts, there was an action class that you subclassed, and in Spring Web MVC, there was a controller interface that you implemented. And Spring Web MVC won out because they had this nice green arrow from their terrible controller implementation to this nice controller interface that I could implement. The rest of the system talked to controller through this simple contract, and I didn't have to worry about the details. I wasn't inheriting implementation that was somewhere in the horrible outside world. The very first time I tried to do test-first programming with a struts action, I got screwed up by a last modified timestamp which was stuck directly to the system clock and made all my tests impossible to repeat because they were all stuck on the system clock. That's the thing that leads you to do crazy things like in the Ruby world we have time cop. Let's freeze time. How about let's not depend on it in the first place? Now, this green arrow from the DMZ to the horrible outside world, we need. We don't have a choice because of the next rule. This is a red arrow. If you draw this red arrow from the happy zone to the DMZ, we have to have a chat. That's a bad idea. This red arrow, which is a little thicker and a little redder, if you draw this red arrow from the happy zone to the horrible outside world, you're fired. Now, maybe you're not fired right away, but if you keep drawing this red arrow and you keep drawing this red arrow and you insist on drawing this red arrow, eventually you are fired. This is an extremely bad idea. And yet, this is exactly what many frameworks encourage you to do. I call it the creepy hug problem. It's nice to be hugged unless the hug is a little bit too long and a little bit too tight by somebody you don't know that well. Now, the good news is that we can replace these red arrows with green arrows. Here's the first example. If you find yourself drawing this first red arrow, then you can turn that into a green arrow by extracting an interface for the thing in the DMZ. That interface then moves into the happy zone, as long as it doesn't depend on any terrifying types. And then the code that used to talk to the DMZ talks to that interface, and you push the connection for those two implementations together up the call stack. And I don't know that I'm talking to something in the DMZ. Something can connect me to the DMZ, and I don't know that I'm talking to it. Everybody wins. We end up with the DMZ talking to the happy zone, but not the other way around. Now, occasionally you can draw this exact same green arrow from the horrible outside world into the happy zone, as for example, Spring Web MVC's controller interface. But most of the time you have to compromise. And that's why we need this green arrow up here. You build a little adapter. That adapter essentially hides the fact that you're talking to the horrible outside world. I like to call this a narrowing API or a pattern of usage API. These are the 4 parts of the outside world that you actually care about, and then expose that through an interface, and now you have essentially a combination of that green arrow and that green arrow. And by doing this, what you can do is essentially rehabilitate your design. These 4 arrows are where we need integrated tests. These are where we need tests that connect our stuff to the horrible outside world, because mocking that stuff is a horrible idea. And if you don't know why it's a horrible idea, then you need to go read the paper Mock Roles, Not Objects. And if you do know why this is a horrible idea, then it's possible you have written one of those articles that says how terrible mock objects are. Mock objects are not the problem here. They are, in fact, the canary in the coal mine. They're the thing telling you that you're drawing these damn red arrows and you should stop. The mock objects are doing their job. So the blue circles are the areas where we need integrated tests. We write as few of those as we possibly can. One of the strategies over time is to try to move code into the happy zone as much as possible. So if you have something in the DMZ and you notice that 60% of that code doesn't actually talk to the horrible outside world, split it in 2. The part that doesn't know about the horrible outside world magically moves into the happy zone, and the rest stays behind in the DMZ. And you have that green arrow in the northeast. And your objective over time is essentially to move code into the happy zone. You probably end up writing a bunch of code in the DMZ to start because I need to connect to the real thing to figure out what the hell is going on. And once I have an idea what the hell is going on, then I can gradually pull things apart, and a lot of those things that I extract can move into the happy zone. Because the red arrows are where legacy code comes from. Legacy code is 1.37 million red arrows. We're going to dive into the details of how we actually apply this tomorrow afternoon or tomorrow all day in my workshop. I'm not here to do a sales pitch. It just so happens that the two are related. So one of the things that I like about this model is that now I have groups who are talking to each other about design in terms of red arrows. They're seeing red arrows and they're talking about plans to get rid of them. If you find yourself drawing a red arrow, don't panic. As I said, sometimes you need to do that in order to get something to work, in order to figure out how this outside system behaves, or to figure out how this library works. You need to connect to it directly and play around with it for a while. And you're going to draw some red arrows. But as soon as you draw a red arrow in production code, priority one becomes turning it into one of these green arrows. And the good news is that there are a handful of purely mechanical refactorings that you can do to turn the red arrows into green arrows. The nice thing about this model for me, which I like to call the universal architecture because it always works. By the way, if you look at this and think, wow, this sounds an awful lot like the hexagonal architecture or ports and adapters, yeah. All roads lead to the same place if it's a good place. The universal architecture gave me a clear model for how to rescue the design of a specific system. And I use this to, and this is a phrase that I want to teach you all, because when somebody asks you why you're spending all this time refactoring and you want a good answer, you just tell them that I'm doing it to reduce volatility and the marginal cost of features. Duh. Reduce volatility, reduce uncertainty. Every executive should love that. Marginal cost, marginal just means the cost of the next one. So I don't refactor because it makes my code elegant. I don't refactor because it makes my code easy to maintain. I refactor because I'm in it for the money. Reduce volatility and the marginal cost of features. It turns out that when we reduce volatility, we actually reduce cost as well. Now, the universal architecture gave me a way to think about how to rescue code. One of the nice things about this is if I notice that I have a bunch of red arrows all over the place, now I have a plan. I know exactly how to deal with it. It's not just this amorphous blob of shit anymore. It's something that I can tackle. The problem is it is 1.37 million red arrows, and that's going to take a while. So the universal architecture gave me a clear way to proceed, but unfortunately, it gave me a whole bunch of tedious work to do. And I remember Planning Extreme Programming, the book Planning Extreme Programming, which taught me to reframe the idea of I don't have time into I have too much to do. The single most important part of that book is that one chapter entitled Too Much to Do. It's very easy for you to look at all these red arrows and say, ain't nobody got time for that. But it's much more interesting to say, I have too much to do, and I have to figure out what to do about that. Because when you say I don't have time, the only thing people think of is I need to go faster. But if you say that you have too much to do, then all of a sudden, not doing some of it becomes an option. Ah, there's that idea again, from getting things done, from extreme programming. The idea of figuring out what not to do and not doing it. This model gave me a way to figure out what needs to be done, and then I needed a way to figure out when to do it all, and perhaps when not to do some of it. Practicing test-driven development showed me the power of using tests to remind me when to stop writing code, so that saved me some energy. Getting things done helped me figure out how to build this trusted system so that the significant work would get done before it became too urgent. But there was one piece of the puzzle missing. How do I know which of these red arrows is my biggest problem right now? Or how do I know where to start? And I started to learn about theory of constraints. Actually, let me come back. I started to learn about the theory of constraints. This gave me a tool for figuring out which problem needed my immediate attention. But before I get there, Pardon me a moment. Yes. So how do I know which work to do? How do I know what I should be doing? What's next in the proven path to effectiveness? Well, I can tell you that this is not the answer. I don't usually like to say things like this, but this is one time when it really fits. Passion is bullshit. And the reason that passion is bullshit is not because passion doesn't work. It's because the success literature has turned passion into this thing that you're a bad person if you don't have. You know, this idea that if you love what you do, then you never work a day in your life. Nonsense. A job is a way of exchanging time for money. Occasionally you get to do work at your job. Sometimes you end up having to do your work away from your job. Passion has little to do with it. You don't need passion in order to do good work. You need a plan. I find this model works much better. So you can see here that if you have only two of these three things, tolerable time commitment, sustains your energy, generates enough money, well, if you have only two of those things, then you could be anywhere in comfortable rut, obsession, golden handcuffs, one of those things. If you have, say, enough money and a tolerable time commitment, but your job is sucking your energy, then you end up in depression. And if you have a job that generates a lot of money and sustains your energy but takes up too much of your time, then that leads to divorce. And if you have a job that is a reasonable time commitment and sustains your energy but doesn't generate enough money, that's a hobby. That's volunteer work. You need a different job. This model encouraged me to think differently about what to do, about what should I be working on. And in moving in the direction of building a dream job, what that really enabled me to do was to spend more of my time doing great work, even if it wasn't my job. Like I said earlier, I can't get anyone to pay me to teach them getting things done, but we end up talking about getting things done in every single test-driven development course, in every single legacy code course. It gets in there at some point. And I really have to thank MindMinds for now being willing to do some mob programming sessions with me so that I can take one step closer to having a dream job, because I love the idea of being able to help people and not worry about getting paid. Theory of constraints, which I won't get into here because I am running low on time, essentially gives me a clear model for figuring out how to sequence work. The very short version is this. There's this notion of a constraint in a system, they call it the bottleneck, that limits how much stuff can flow through the system. And the bottleneck helps you understand which problem needs your most urgent attention. You have 137 improvements you want to make. Which one should you try first? The one that's at the bottleneck. And so then agile software development is no longer this idea of a video game with levels to conquer. You don't get points for being more mature. What you get points for is for picking the solution to your most urgent problem. You find where your bottleneck is, and then you reach in your bag of tricks and figure out what might help solve that problem. And that is one way that I learned to adopt practices in a way that was compelling to everyone. Instead of being the typical consultant pushing solutions at people and being completely out of balance, I learned how to use a combination of the theory of constraints and agile software development to help groups solve the problem that mattered to them when they needed to solve it. The pain, the principle, and the trick arrive at the same time. We don't just tell them to do these practices because they're good for them. We look at what their problems are, we map value streams, we figure out where the bottleneck is, and then we reach into our bag of tricks and say, aha, bugs is your problem, you need test-first programming. Design is your problem, you need evolutionary design. Test-driven development is a good way to do it. See, I had gone around Europe in 2011 screaming about the fact that we did it all wrong, and then the next year again trying to figure out where it is that I think we wanted to go. And I'm back here again saying, well, here's a bunch of things that we did wrong and how we can do it better. There needs to be a better way. Even though everything has already been said, nobody was listening. So we have to say it again. As I say, I stopped seeing Agile as a video game with levels to conquer, but rather as a bag of tricks that help me fix bottlenecks. When they talk about being agile about Agile, this is one way to do it. This gives teams the feeling that they are solving real problems that matter to them instead of following yet another set of rules that another group of highly paid consultants have been brought in to teach. Congratulations that you've read the Scrum Guide. I think that's wonderful. But if all you're going to do is tell us to do the daily stand-up and retrospectives and put everything on sticky notes, that's not solving a problem that matters to us right now. How about listening to us? Trying to push solutions like that is falling completely out of balance. And this was a way for me to regain balance and to help groups improve in a way that was compelling to them. Unfortunately, this work, as interesting as it is, led to the last huge bit of pain. And that has bad interactions with people. And so I needed to learn a way to interact with people in a way that worked better. I was acting arrogant, abrasive, judgmental. And I needed something that would help. Because I kept falling into the trap of the fundamental irony of interaction, which is that when somebody does something that you don't like, you're probably going to criticize what they're doing when their reaction, the thing that they're doing, is probably the thing that's hardest for them to change. I needed a new trick. The trick that I learned was the satir interaction model. Here's the short version. There are 4 stages to an interaction: intake, meaning, significance, and response. Intake has to do with, did I see what I thought I saw? Did I hear what I thought I heard? Meaning has to do with, do I understand what those words mean? Significance has to do with, why is he doing that? Why did he say that at this moment? Why is he sitting at the desk in this meeting, leaning back in this closed stance? And then response is how you respond. And the fundamental irony of interaction is that when somebody responds in a way that you don't like, you're going to have the impulse to criticize their reaction and try to fix it. And that just isn't going to work. The one thing that I had to learn was that the path from significance to response is extremely difficult to change. It's based on deep cultural conditioning. It's based on everything you learned about how to behave from the moment you were this high and people were yelling at you for being too loud, for running around, for speaking up when you shouldn't speak, for using words that we don't say among other people. These are only daddy's words that he says at home. The path from significance to response, from interpreting what's happening in the world to reacting to it, we used to think it's hardwired, but it's not that. It's deeply conditioned, which means that if you focus on criticizing people's reactions, you're not going to get anywhere, even though that is the thing that you see. If you want to improve your interactions with people, use the trick that I learned. Help them understand or help them interpret the situation differently. When somebody yells at you because they didn't like the way you said something, they didn't like your tone of voice, help them understand, offer them a different interpretation of what's going on. You know, I really am on your side, don't you? I promise this isn't a passive-aggressive voice. I'm just trying to remain calm. I'm folding my arms not because this is a closed stance, but because I'm cold and this is how I keep myself warm. I'm looking away from you when I listen to you, not because I don't care, but because this is the only way I can hear you in this crowd. If you offer people different interpretations, then they will lead to different reactions. And so if you find that you have difficulty with interactions with people, I'm guessing everyone in this room does, because, you're human. The satir interaction model gave me a great way of understanding how to debug. At first, I thought I was debugging other people, and I realized that I was actually debugging myself. Because it's not enough just to think about the path of offering other people different interpretations for what's going on in the hopes of changing their reaction. The real magic happens when you start examining your own interpretations and look for different ways to understand what's happening so that you change your reaction. So these are some of the tricks that have helped me along the way. The tricks that are helping me the most these days are these ones. Meditation is wonderful. There's really nothing quite so lovely as telling your chattering brain that you don't need to think about that right now. It's okay, you can think about that later. The satir interaction model continues to help me. I'm by no means a master at it. I'm just kind of not terrible anymore. Transforming rules into guides is another one of those wonderful techniques. If you don't know what that is, I recommend looking it up. It's very powerful. And moving details up the call stack. I mean, I still write code. We still write code. And moving details up the call stack just means that it's easier for me to change things, and the stuff that's unstable doesn't have that many clients, and the stuff that has lots of clients is stable. These are the tricks that are really helping me right now. That's not to say that you need to go and learn these tricks and put them into practice. You need to match the pain and the principle and the trick. Sometimes you have to wait for them all to arrive. Sometimes you have two and not the other one. Somebody tries to give you advice and it just doesn't work for you. That's okay. Maybe you just don't understand how it's meant to work. Or somebody gives you this high-level principle that's true but useless because you have no idea how to get started. The last thing I want to share is a model of motivation. People will tend to do things if they know what to do, if they have an idea what will happen, and they want that to happen. And so if you have this really great idea for what people should be doing, if you are like I was at IBM, running up and down the halls, waving your hand saying, we got to do this, and nobody's listening, you can be sure that one of these three things is missing. The manager who orders training thinking that that will magically whip everyone into shape assumes that the first one is the problem. Often it isn't. I've seen groups where as soon as the testers hear that the programmers are starting to do test-driven development, they think, well, shit, what job will I have? We got to stop this in its tracks. Because they knew how to do it, and they saw what would happen, and they did not want that to happen. So these are just some of the tricks that I use. Please keep in mind that none of these things happen quickly. Improvement tends to follow an exponential curve, which means that you do a whole lot of work and don't see lots of results until suddenly everything magic happens. The problem with the exponential curve is you can't tell where you are. It looks the same from everywhere. But if you keep at it, trust me, you will get there. I looked at my bottlenecks, I reached into my bag of tricks, and when I didn't have a trick, I asked around. I surrounded myself with a community of people who wanted to help me. And then I became part of the community that wanted to help other people. Here's a trick, a marketing thing you need to know about marketing for consultants. We need to be seen answering your questions in public. We need to be seen answering your questions in public. That's how we establish our credibility. That's how we show ourselves to be extremely smart, likable, sexy people. And so when you ask people questions, you're not bothering them. You're not taking them out of their day. You're giving them fuel for their marketing engine. So ask away. Corner them. Ask them. Send them emails. Go wherever you need to go. Ask as many questions as you can. When you don't understand something, ask. We need to answer your questions. That's how we eat. And I promise, if you ask questions of me, I will try to help. Eventually. My energy level isn't as high as it used to be. And so these are a bunch of tricks. When the pain, the principle, and the trick come together, then you know how to do something, you know it will happen, and you probably want that to happen, and you'll finally move forward. It takes time, don't worry. Some of the most wonderful things take just, say, 27 years of practice. This is how you can find me. If you'd like to ask a question, please go to ask.jbrains.ca. For those of you who are coming to my workshop tomorrow, see you then. Until then, achu, gyerkime vinna.